Have you seen use function stringlen or a fully qualified count with namespace operator in a codebase before and thought, this seems pointless and annoying? Technically, it's not needed. Function calls in PHP automatically fall back to the global namespace if they are not defined in the current namespace they are called in. But there's a hidden performance gem in the PHP compiler and opcache that can optimize function calls under special circumstances. In this video, I'm going to explain compiler-optimized functions and discuss if it's worth it to migrate your codebase to use them. Moin, I'm Benjamin and I'm working on PHP performance-related topics for the last 10 years, helping thousands of developers, companies and open source projects along the way. In a recent Reddit post titled Excessive Micro-Optimization, Did You Know?, the author shows a code benchmark example of timing stringlen against a globally imported stringlen and asks if the impressive performance gains are visible in real-world applications. The feature they described is called compiler-optimized functions, and it's only activated for a list of hard-coded functions that are listed in the zen_compile_c file in the PHP source code. Most importantly, they need to be imported directly and can't rely on the automatic fallback mechanism in PHP. The list includes functions such as stringlen, count, sprintf, and many is, array, is object type, checking functions, and others. When the compiler encounters them called without relying on the fallback mechanism, unambiguously from the global namespace, then this optimization kicks in. You can see the difference by looking at opcodes that PHP emits when compiling the different code examples. You can see opcodes of a script by running PHP on the CLI with a special flag. So in this case here, PHP, we enable opcache and opcache debug level to a certain bit mask. And then we run this on our stringlen namespace example where we don't import the function. And there we can see that we initialize a namespace function call by name, app string repeat, also initial function call by name, app stringlen, and then a generic function call, do function call by name. And then if we compare the same with the script imported from global, then instead of the generic opcodes, we can see that we use a specialized stringlen opcode here. You might raise the point that this sounds like a micro-optimization, and you are correct. Nevertheless, let me measure the difference of this optimization in a made-up synthetic benchmark that calls stringlen 1 million times, and we use Hyperfine to measure the difference. Hyperfine is a benchmarking tool that takes care of statistical averaging and making sure that the load on the machine is comparable between runs, and then calculates the values so that we can actually make out a good difference. So I'm running the command here with the -v flag, which is W, which is warm-up runs. Then I'm calling the benchmark compiler optimized code, which uses the namespace argument here. So benchmark compiler optimized PHP against the version which is using the fallback mechanism. So PHP benchmark fallback mechanism.php. It then runs the scripts multiple times and compares the output with each other. In this case, we can see here the compiler optimized version runs 1.46 times faster with a statistical corridor of 0.24 times faster or slower than this value. So it's really about 20 to 60% faster than not using using the fallback mechanism. For open source code, you could argue that it should be a matter of good style to provide the lowest overhead possible, but for your own application code, this optimization is less important. But there are cases where this optimization does matter as well. When you call these compiler optimized functions hundreds of thousands of times in your application code and it already has a low response time in the 20 to 200 milliseconds range. Then you will see a difference when compiler optimized functions take up a huge share. Granted, these cases are rare, but it's good to having heard about this optimization nonetheless. In PHP 8.4, my colleague Tim added sprintf to the list of compiler optimized functions. If you use only the %s and %d modifiers, then PHP and opcache can optimize the sprintf calls down to native string interpolation. This allows you to migrate your code from using string interpolation to a more readable sprintf code with no performance penalty due to function call overhead. There are a few ways to automatically convert your code to use global namespace imports that I want to quickly show you. You'll find them in the blog post "What are compiler optimized internal PHP functions?" in the middle somewhere. So the first one is the PHP CS fixer. And you can run that one with the argument fix for source, allow risk yes, and rules native function invocations. And if you do that, in this our case here on the PHP RFC watch project that I have, you'll see it will append all the compiler optimized functions with a slash, but not the ones that are not compiler optimized. The second option is to use PHP code sniffer. And you can see here, if you use the rule set reference use names only and then run PHP CBF, it will make this change. This requires the Slevomat coding standard. And this makes a few changes, and to look at the file here, we are using this rule set, and we can look at the changes here. It does a little bit more. It also imports classes, makes sure everything is referenced there. And it seems that, at least in the version I looked at here, it's not perfect because it only imports the assert function, but it didn't import the count function or string length function. So it does not do everything. And to my knowledge, previously it even referenced all functions from the global namespace, regardless of them being compiler optimized or not. So the PHP code sniffer approach is a little bit less powerful than PHP CS fixer. The third option is, and I only found that through the PHP Reddit thread on compiler optimized functions, is to use PHP Storm's general auto import to don't prefer the fallback, but prefer full qualified name. So in that case, for example, if I have an assert call here, I can write assert, and if I autocomplete it, then it uses the import automatically. But this one is done for all the functions, so also the ones that are not compiler optimized. So should you import functions that the compiler can optimize for performance reasons? The answer is, it depends. When the overhead is significant, then yes, otherwise you could ignore this as being too micro in optimization. Tideways Profiler can automatically detect if you have code that would benefit from this optimization, and across all our customers, this happens in maybe 2 to 5% of customers. For example, here in this example, when 20k calls to in-array cost 349 milliseconds, or in this other case of a customer where array key exists was called 9,550 times and it took like about 10 milliseconds to do that. For each of these cases, there's a compiler optimization available, and if you import them, you will see some improvements. Obviously, these functions calls won't go down to 0, so it's not like they are completely free afterwards, but you will see them take way less time than the time measured in a profiler. If engine optimizations are interesting for you, I made a recent video on opcode specializations, a similar hidden gem in the engine. And if you're interested in PHP performance topics in general, please subscribe to our channel or our newsletter. The link is in the description. Bye!